Yeah, so basically we're here to talk a little bit about Kotlin in a very general way. So I hope that you guys have been enjoying the conference so far, as I am. I encourage you guys to take advantage of all the speakers that came for all over the world to be with you guys, to share the knowledge, to share ideas, and to be able to connect with you. So don't hesitate, go ask questions. There's no stupid question, most of the questions that you don't ask. So go. Without further ado, I prefer to change the name of the talk to Let's Talk About Kotlin in a more general way. So my idea of this talk is a little bit to talk how Kotlin could improve the developer experience. How many of you guys are using Kotlin in production? Okay, good. That's less than 10% of the people. So my talk is oriented for all those people that are using Java. So I'm expecting the rest of the people are using Java nowadays. Yes? Oh, cool. So that was the main purpose of the talk, to try to sell you why you should start using Kotlin, because that was the way I was by to it. So the main purpose will be not to give you tips and tricks. It will be mainly to give you a reason why you should try it, at least. I would say that it's like people say, once you try Kotlin, there's no way back to Java. Yes. Yeah. So this is going to be my agenda today. So we will talk a little bit about why a new language, but mainly why Kotlin. A little bit about the background. I will explain some cases that you guys could be familiar with, and at the end I will give you some recommendations. So who I am? My name is Branagan. I'm basically doing a lot of mobile development for 2009. Right now I'm working as a CTO for a payments company based in Dominican Republic. And I like to mentor a lot. So right now I'm mentoring a group of kids doing robotics. And every year I run some kind of summer camp for kids, mainly for ages 12 to 17. And if you guys have any interest in talking or finding a way how to get people into technology, mainly software development, send me a message through Twitter. So I'm from Dominican Republic. If you don't know where it is, it's in the Caribbean. So to give you an idea how much time it took me to be here, so I went to New York. It's like 3 hours, 45 minutes, and then 8 hours, 50 minutes. But that took me 2 days because I missed my first flight. So the important thing is I'm here. So another big difference from being in Kyiv versus my country, you see? So I'm expecting most of the people over there are wearing like hoodies, because for us, that's almost winter. So the coldest weather that you can see, the lowest level of the weather you can see is almost pretty close to 20 degrees. So this is how it works. I'm kidding. But yeah, we are pretty close to the beach. So let's go to the talk. So why a new language? If you guys like a little bit of history, languages have been coming and coming a lot. But the main idea from the different languages that we have been seeing coming during the times is because they wanted to like take advantage of, or maybe became the most popular language in the world to take, like, let's say, let's use a word for that. Let's say like be the dominant programming language for all the programmers in the world. So starting from the 1970s, C became the first language that actually dominated the world, mainly because they were able to like use low-level and high-level languages using the same language. So the project that were used to make the C case as a programming language was to build Unix. So it was built for the ground up, everything from C. Later in the 1980s, where maybe most of us are very familiar, is Java. Java became like the new C. So it improved a lot of things that people used to tend to do in C in a very, very different way. So, but the main objective of bringing Java to the world was actually to be able to run the same code. As you write the code one time, you'd be able to run it in different places. because when we're using C, we needed to compile the code for each computer that we wanted to run the code. So Java, as it using the JVM, the one that we know as the JVM, is something that works across environments. So you only need to be aware of one specific code, one specific language, one specific structure. It doesn't matter where you test it, the code is going to run everywhere. So that's why Java became very popular in the 90s until this day. So the problems that different languages have trying to solve are, if you try to answer those questions, there are many languages that are trying to replace Java in different ways. So I will mention a few of them, not all of them. But over the 2 decades, seeing the trend that every 20 years, like there's a new language that's trying to take over the world and make everybody to use it. So we can say that now is the time where we can maybe starting to figure out which one is going to become that language. So this graph basically shows you guys that Java is still being the first or the most popular programming language in the industry after 15 years. So, I mean, you still having jobs, so no problem with that. So, even though we have new languages that have trying to come up, they never reach the limit or reach the promise of all the things that all the questions that we put before, because they don't answer it. So, I would say what programming languages I'm talking about, the ones that I'm trying to replace Java in the modern days. So let's start with .NET. .NET has become the long-time rival for Java. But the main problem with .NET at the beginning was the technology was proprietary. So it was a little bit difficult, as Java was open source. The tools that we were using were open source too. It was very hard for the developer community to actually start using .NET. That's why you see the separation. The people that are more in the different kind of corporate environments are using more .NET than Java. In some countries, you may see that there's more Java developers than Kotlin the .NET developers, or the opposite, depending which company is actually making more effort to bring developers on those areas. So in the other case, we have Ruby and Python. The big problem with these two languages was they took away the static typing support. So we feel that they are a little bit slower. Yeah, they are very easy to write code. With less code, you write more functionality. But man, at the end, we figured out that we have more problems. We are not using type languages. Scala, in the other way, didn't sacrifice the type safety, but the problem was too complex for the majority of the developers. It's still being like that. But the risk of that is like, I would like to use it as a reference as JavaScript. The problem with Scala is like you sit one developer today, if you close that person for 1 week, if you come back like 2 weeks later, maybe he will not understand the same code that he wrote like 2 weeks ago. The same happened with Scala. It's the same problem that I've seen with JavaScript and Scala. So why Kotlin? Unlike the other languages that we mentioned before, Kotlin has tried to use the power of Java and just trying to use all the different features that people are trying to enhance in a more different way, in a more modern way. So the strategy of Kotlin is basically these 4 pillars. One is being interoperability with Java. So you can write code from Kotlin to Java and the opposite. So it's more concise. You can write less code and provide the same functionality as you do in Java. The third one is to be more robust. So you will get less errors writing code on Kotlin. I don't want to talk right now about the null pointer exception, but that's one of the big promises that people are trying to use. And the fourth one is the tools. All the tools that we have nowadays that make easier or provide better journey for us to start using Kotlin as a daily tool. So what do we mean with interoperability? As I mentioned, it's possible for you make calls or still using your Java APIs, your Java libraries for Kotlin. It's the same from the opposite side. The only thing that you need to take in consideration why you are migrating or using those libraries is that sometimes the type safely, like the null check or those things, you need to take care of that on Kotlin. But it's something that for you, I mean, will be quite easy to use it without any problems. So Kotlin is very concise and expressive. So expressive in the meaning that you bring someone that doesn't know the language, it will be quite easy for that person to understand what you're writing. So he doesn't need to understand actually the logic of the code, how understand the language, the syntax. Just seeing the code is very expressive to understand what the people is trying to write. So this is, for example, one example that meaning what it means writing less code and you get a lot of functionality. We know what is a pollo, right? You need to write all the members, prepare the setter and getters. If you want to override, for example, equals, you also need to implement the hash code. So with one line, you maybe are taking away 15 to 20 lines of code in Java. So, you know, we can improve something. We can dedicate the time maybe to drink coffee instead of continue writing pollos. More robust. Kotlin is a big step forward addressing the null pointer exception or the null pointer error or the $1 million mistake, because by default they made the developer to be very specific that you want to use nulls values. So it's easier to maintain. You don't have to be too defensive writing code in Kotlin. So it gives you like a more robust code, and in some cases you can easier like make the case with the business in order to sell the Kotlin for the company or maybe to your manager. So basically, this is a function which is using a type Nonnullable. So it's very, very difficult for you to receive from that function a null value because it's very specific by the language. So lastly, the IDE support. We all know who created the Kotlin. So JetBrains are the ones who are providing the better tools nowadays as IDEs. So you don't need to know a lot of Kotlin to start like experience to having the experience of using a modern language. Because if you start using the IDE, not typing in a single test editor, they will give you a lot of suggestions. They will give you a lot of errors like before compiling. So they are pretty awesome tools. So wrapping up what we were talking about. So these are like the 5 pillars of Kotlin: the static typing, the be concise and expressive, the being a JVM language make Kotlin very cross-platform, I would say. And also Kotlin has built-in node safety. These are the 5 pillars. You can see it that way. So I mentioned during my talk that I'm going to talk about effective Kotlin. So the idea is to make a reflection about this book. How many of you already read this book? The first one? It's almost the same. Yeah. But yeah, so this book is like the Bible of Kotlin. If you are able to start using Kotlin in IntelliJ and you try to decompile all the code that they are creating for you in Kotlin, most of the things that you will see are items that we're reading on this book. For example, I will start mentioning some items from the book that doesn't even apply for Kotlin because they were removed because JetBrains or the Kotlin language is taking care for us about that. For example, Singletons. This is one of the main items there is in the book, where you need to enforce the singleton property with a private constructor or an enum type. This is the way how you do it in Kotlin. So You guys probably know how many lines it will take you in Java. Exactly, something similar. Yeah. So it's quite easy for you to understand. Even though you don't know Kotlin, you know what we're doing here. So you have a function, and you have a property directly on the class, on the object. You just need to declare an object, and the language automatically will create a singleton for you. Once you create something as an object, it will provide you as a singleton for you as a free. You need to actually do any implementation for that. So the item 16, so in public classes, you should not use public fields. So this is a Java way, how we are pretty used to do it. Every POJO, every class that we don't want the members to be public is the way we do it. In Kotlin, you are not obligated to provide implementations for setters and getters, because they have data classes, as I mentioned before at the beginning of the talk. But you can extend that and override those methods. So this is a way how you can enforce some functionalities if you need to do it in order to provide setters and getters for one specific class. Quite simple. So you're still like enforcing and making sure the behavior that you wanted to maintain will work. So the item 40. So this one is, we all know that in Java, it is not required to override any methods, even though you are doing an implementation of interface. Kotlin doesn't allow you to do that. You are obligated to do it. So as a developer, it's quite easier for you to see that you are actually providing a new implementation for some methods. In Java, you never know. You guys knew it, because we are not obligated to do it. You maybe have it will compile, but you maybe will receive a runtime exception or error. You never know. But it will compile in Java. In Kotlin, it will not allow you to do it. So one part very important, I didn't want it to actually reflect it with one specific item from the book, is nullability. Because there are many examples, many patterns that we can figure out how to solve. But the null pointerization is one of the, I would say, the fears that we as Java developers have. But Kotlin, for example, I will give you one specific example. How many of you guys are using Spring, for example, Spring Framework? Using Kotlin, probably you will be null safe with Spring. By default, I mean, for scratch. I mean, if you're writing code from Kotlin, no, I'm not saying the same code that you have in Java. Using the Spring Framework as a library from a Kotlin code, you will be almost null pointerization free. You need to be very specific, and where do you want to throw that exception in the part of the code. So it's something that you guys can take advantage of right away. To give you one example in Kotlin, it's very important to understand what is a type or class. It's a little bit confused for us, because you see on the right side of the screen that we have the classes of the members that we know, Boolean, string, class, unit. But on that side, you see that all the classes have like a question mark. The question marks means that that particular class of type could be nullable, but you need to specify it. That's not by default. This is what is recommended, but you also can provide you can provide a value or a class that could be nullable. A simple sample could be this. On the top we have a normal string. If you try to assign a null to that member or to that variable, it will give you an error in compilation time right away. But the second one, I mean, you need to take care of the nullability. Using in different cases, for example, I would like to explain a little bit better what is the difference, for example, in this case, what is a class and what is a type in Kotlin. For example, on the first one, we have a val string without the question mark. In this case, the string is a class, but it's also a type. But in the other case, we see that in this case that we're using the question mark, the string with the question mark means that it's a type string, which is something that is nullable. If we wanted to talk about just the nullability of Kotlin, we could spend like the rest of the day. But it's something that is very powerful for the language. Some takeaways for you as a Java developer that will make your life very, very efficient, or your code will be more performance-oriented better. For example, there's a couple of things in Kotlin that make you like have superpowers. The second one, extension functions, that allow you to provide specific implementation even though you don't know the code or you don't have the source code. You can extend, for example, a class like a string, and you can provide your own implementation. And the first one is something that I noticed that give you a lot of advantage in performance. We are very used to using in Java lazy initialization, but we need to declare all the variables or either null or either with one value. In Kotlin, you have this late init, which actually doesn't have a reference to nothing until the moment that you created a reference. So it's something that gives you the compiler and the interpreter a little more, it's more easier for the compiler to understand. Couple reference that you could use. This is like the Bible for Kotlin, Kotlin in action. You can check this book. And also check the reference because JetBrains have been updated a lot. All the documentation, the community is very big in Kotlin, mainly because, for example, Google is supporting Kotlin as the first language for Android. So there's a lot of guys doing mobile. They also doing Kotlin. So the main reason why I decided to start using Kotlin is because they support multi-platform. So we can write one library and make this library be cross-platform. So you can have one library, share this library with one mobile application, a web application, and also with your backend. So imagine that you have like some business logic that you can provide cross-platforms. So Kotlin could be something that can provide the value for you. So I think that's it. If you guys have any questions, so I'm open to take it.